Okay, so let's look at the following GCSE physics past questions based on the topic isotopes and nuclear reactions. Let's check it out together. Alright, so here is the first question. Some isotopes emit nuclear radiation. Carbon-14 and carbon-12 are isotopes of carbon. Compare the structure of an atom of carbon-14 with the structure of an atom of carbon-12. So, number one, can see that both, since they are isotopes, we can say both atoms or both nuclei contains 6 number of protons. And number two, we can say that carbon 12 has 6 neutrons, while carbon 14 has 8 neutrons. So number two, carbon 14 is a radioactive isotope. Carbon 14 has a half-life of 5,700 years. So what does half-life of 5,700 years mean? So it actually means, that the time it takes for the radiation which is being emitted by a radioactive sample to become half is 5,700 years. So from this table gives the half-life of some other radioactive isotopes. Then you ask, a sample of fluorine-17 has an activity that is 1/4. So 1/4 refers to 2 half-lives of its original activity. Calculate the age of the sample of fluorine-17. So fluorine-17, one half-life is 64.37. So one half-life is 64.37 seconds. So therefore, 2 half-life will now be 64.37 multiplied by 2, which is 128.74, or approximately 129 seconds. All of the isotopes in table 1 emit beta radiation. Explain which isotope will cause the biggest risk to a person's health based only on the half-life of each isotope. Alright, so from the half-life here, we can see that nitrogen 18 will emit the most radiation per second because that's the lowest. Alright, so we can say nitrogen 18 has the greatest activity. Why? Because it emits the most radiation per second. So number 5 now. People who work in the nuclear power industry needs to be aware of irradiation and contamination. Describe the difference between irradiation and contamination. So irradiation means the absorption of radiation of an object or a person to radiation. So in the case of contamination, it is the unwanted presence of radioactive material or atoms inside of a person. Alright, so let's look at the next question. Give one health risk to a person working close to a source of radiation nuclear reaction. So we have the risk of cancer or tumors. So another one is radiation poisoning. The risk of radiation poisoning. So we have to mention one. Any one out of these two is correct. Number 7, workers in the nuclear power stations are monitored to check the radiation they emit. A worker stands 1 centimeter away from a radiation detector. The amount of radiation the worker emits is recorded. Explain why the worker needs to stand close to the radiation detector. So this is because some radioactive materials do emit alpha radiation. So this has a weak penetration for a short range in the air. And here is the last question. Workers in the nuclear power industry are exposed to nuclear radiation. Pilots on aircraft are exposed to cosmic radiation from space. Daily dose caused by working in a nuclear power station is 0.00050 millisieverts. Hourly dose from cosmic rays to a pilot while flying is 0.0030 millisieverts. Calculate the number of days it takes for a nuclear power station worker to receive the same dose as a pilot flying for 24 hours. So we have for pilots dose in 24 hours, that will be 0.0030 multiplied by 24, which will give us 0.072 millisieverts. So number of days will now be 0.072 divided by 0.0050, which will give us 144 days. Now for the nuclear worker, so the hourly dose will be 0.00050 divided by 24, which will give us 0.0000208 millisieverts. So number of days now will be 0.0030 divided by 0.0000208, which also gives us 144 days. So you can see both of them gives us 144 days. Thank you all. God bless you.